Okay, we're seeing how we can convert class limits into class boundaries. The reason why we convert a class limit into a class boundary is because we want to accommodate for decimal numbers that may be in our data. Basically, we're trying to account for continuous data. So if we look at this first class interval, 0 to 9, then the next class interval, 10 to 19, what we notice is if there are any decimals like 9.1, 9.2, 9.3, they're not accounted for. Okay, even if you look at this class 10 to 19, then we move to the next one, 20 to 19. Decimals like 19.1, 19.2, they're not accounted for. Okay, so to account for these decimals, or basically this gap, that's why we introduce the class boundaries. Okay, so to get the class boundary, what you need to do, okay, we'll look at our first interval 0 to 9, then 10 to 19. So we focus on these numbers 9 and 10. All right, so we just subtract them. 10 minus 9, that is 1. Okay, then this one, we just divide it by 2. We're going to get 0.5. So this 0.5, we're going to be subtracting it from our lower limits, which is the left side, and we'll be adding it to our upper limits, which is the right side. Okay, so on the left side, these numbers on the left, we're going to subtract by 0.5. Okay, then all the numbers on the right here, we're going to add plus 0.5. Okay, so if we say 0 minus 0.5, we get negative 0.5. 10 minus 0.5, we get 9.5. 20 minus 0.5, 19.5. And on the right, we're adding 9 plus 0.5, you get 9.5. 19 plus 0.5, you get 19.5. 29 plus 0.5, 29.5. So once we have done this, now we have closed the gap and we can accommodate decimals, okay? Decimal numbers to one decimal place. So we can connect them here. As you can see, there is no gap here. So we've accounted for continuous data.